So good afternoon to everyone. So today class is structural geology, 5th semester. So in this we have how many chapters is there? 1, 2, 3, 4 chapters is there, right? 4 units. Okay. So now let's start. So first of all, so now we can say introduction. Introduction of the structural geology, right? So structural geology. So structural geology is the branch of the geology that deals with the recognition, representation, and genetic interpretation of rock structures, right? What is that? It deals with the recognition, representation, and genetic interpretation of the rock structures. What is that? Rock structures, right? Rock structures. ST structures. It means structural geology, right? So it also involves the study of the forces which gives rise to these structures. So the term structural is derived from Latin word. It means STRUERE, structure. So which means to build. It means, what is that? To build. So it is the Latin word structure, STRUERE, right? So it means to build. TO, to build. BUILD, build, right? So now let us define what is structural geology. What is structural geology? So structural geology is the study of the architecture of rocks insofar as it has resulted from deformation. What is that? Resulted from deformation. So structural geology pitamahudu antaru kada. So that is, who is that? Billings in the year of 1990s. So these scientists discovered the structural geology in the year of 1990s, right? So now structural geology, it deals with the geometry and also distribution and formation of structures. And geological structures are rock structures. Those are incorporate symmetry and geometric configuration of rocks present in the earth crust. What is that? Earth crust on all scales, right? So the geologic structures result from the deformation caused by the tectonic forces. What is that? Tectonic. TECTONIC. Tectonic forces. FORCES. Tectonic forces present in the earth. That is, they are endogenic. What is that? Endogenic. So the term tectonics is derived from which word? Greek word tecto. TEKTOS. Tectos. It means builder, right? So structure means to build. So tectos means builder. BUILDER, builder. So tectonics is the study of the forces and motion that result in rock deformation and what is that? Structure. Deformation and structure. So now what is the relationship relationship between structural geology and tectonics. So I already told what is structure and what is tectonic force, right? So now relationship. So let us get acquainted with the relation between structural geology and tectonics, right? So structural geology is mainly concerned with the rock geometry, whereas tectonics deals with the forces and movements. It's responsible for the generation of the rock or geologic structures, right? So now, therefore, both structural geology and tectonics, these structural geology and tectonics, these are responsible for building of the Earth's lithosphere. What is that? Earth lithosphere. So we can say that tectonics is quite closely connected to the underlying processes that cause geologic structures. What is that? Geologic. G-O-L-O-G-I-C. Geologic structures. It's quite closely connected to the underlying process that cause geologic structures, that is to form. So these structures provide information about the forces acting within the earth, right? So the objective of structural geology is to determine and explain the architecture of rocks as observed in the field, right? So the field observations are supported by some laboratory investigations to attain this objective, right? So the geologic structures range in size from microscopic scale. What is that? Microscopic scale. Microscopic scale to, what is that? Hundreds of kilometers. Hundreds of kilometers. Remember this word? So the geologic structures ranges in size from microscopic scale to hundreds of kilometers. Kilometers. Right? So now, basic concepts of structural geology. So what is the basic concepts? This one here, basic concepts of structural geology. So let us get familiarized with some of the basic concept of structural geology before we study about what is that? Various geologic or rock structures. Those are like faults, giants, right? So the study of structural geology um, is mainly what is that accomplished with the study of geological structures which are developed due to formation. What is that? Developed due to formation. So they are also known as deformational structures or secondary structures. What is that? Deformational. Deformational structures or secondary structures, right? So now, what is the primary structures? So these structures form as the result of the processes connected with the deposition of, what is the sediments, right? Sediments. So they are also known as depositional structures such as this bedding planes. Okay, bedding plane. So now the structural geologists plays a significant role in the identification of the geologic structure, their geometry and orientation, the time and sequence of their deposition. So they also assess the physical conditions responsible for the development of these structures. What is that? Primary and secondary structures, right? So let us read about the common terminologies used in the structural geology. That means here outcrop. So what is that? So what is the outcrop? They are exposure of rocks on the surface of the earth. You see here this figure. So this is the outcrop of the surface of the earth. So see here expose of the rocks in which place? Surface of the earth, right? So if the rocks are not exposed on the surface of the earth, what happened? They are referred to as incorp, right? INCORP. It's called incorp. So the outcrops are generally visible along valley walls and river all some of the nala, right? Nala section and mountains and roads or railway cuttings and tunnels, right? So these are some of the outcrops. So hence an outcrop denotes area on surface of the earth over which a rock mass is exposed. That rock mass is exposed. So the line of intersection of the limiting surface of rock mass with surface of ground mass, its limit, right? So the study of geological structures is generally carried by the study of these outcrops. Remember this word, outcrops. So this is the outcrops of the, some of the, what is this rock? Sandstone, right? So this is the horizontal bedding plane. You see these bedding planes here, horizontal. So how it look like? The beds are horizontal, right? Horizontal bedding planes. Now, so layering, layers. So layering, what is the layering? It is developed. It is developed in rocks due to the deposition of sediments, right? That deposition of sediments and rock materials are some of the minerals, right? So the deposition of sediments one over another in a basin results in layered or sedimentary rocks, right? So what is the bed? Bed. This is the bed. So bed is defined as an individual layer or strata of a sedimentary rock. So you see here, these are the beds. So this is one bed and this is another one and this is another one and this is also another one. So this is also another one. So these are the beds, look like this figure, right? So each bed is separated by the adjacent bed by a plane. That is called bedding plane. You see here this line. So this red line. So this is called bedding plane. This is separated by these adjacent beds, right? So if the individual layers are less than 1 centimeters, less than 1 centimeters thickness, right? 1 centimeter thickness, they are called, what is that? less than 1 centimeter, it called lamination. 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 So less than 1 centimeter thickness of the layer, it's called lamination. Right? So the process of deposition of sediments in a layer by layer fashion is known as stratification. Is that stratification? Stratification. Stratification. This is lamination and this is stratification. So lamination means less than 1 centimeter thickness of the layer, that is called lamination. And what is the stratification? The process of deposition of sediments in a layer by layer. Layer by layer, it is known as stratification, right? So you see here, these are the beds and bedding planes and lamination, right? So the bedding planes are formed, bedding planes are found in sedimentary rocks, where in sedimentary rocks only, right? So layering is, or layers are developed in volcanic rocks. Remember this word? So bedding planes are found in sedimentary rocks, but layers is developed in volcanic rocks. Those are called igneous rocks, right? So you see here this figure, like this one. So these are igneous rocks, right? So because of, what is the reason? Lava flow of lava. So it is also referred as primary foliation. This one, primary foliation. So because these are developed simultaneously with formation of the rock. So the term secondary foliation and is used for layers found in metamorphic rocks. Okay, metamorphic rocks. So the layers in metamorphic rocks developed as a result of the development of new minerals and reorientation of mineral practices or particles from pre-existing rocks. During what? The process of metamorphism, right? So the layers in metamorphic rocks develop as a result of the development of some of the new minerals, right? New minerals and reorientation of mineral particles from pre-existing during the process of metamorphism. So examples are static cleavage, ancestosity, and genosity, right? So fall in the category of these secondary foliations. Right? Now, intrusion and deformation. Intrusion. So intrusion means, so igneous bodies can be extrusive or intrusive. We are studying in the previous semester, in the third semester. So we know about the what is extrusive and intrusive rocks, right? So igneous bodies can be extrusive or intrusive. So it means the intrusive rocks are those igneous rocks which penetrate or intrude in a pre-existing host rock. Pre-existing post-rock. So they might have consolidated either at greater depth or great depth or at shallow depth, right? Shallow depth. So in so many times, the layering seen in the intrusive igneous rocks, which can be absorbed in parallelism with the surrounding country rocks. It is also called as host rock, right? What is that? Host, H-O-S-T, host rock. So, but in sometimes, so the igneous bodies cut across the beds of the country rock, and because of their late entry into the system along some joints or cracks, right, or fractures. So we will discuss various types of intrusions based on their geometry later. Okay. Now deformation. So what is the deformation? Deformation. D-E-F-O-R-M-A-T-I-O-N. Deformation. So this deformation applied for a process in which the original rock is modified. What is that? Original rock is modified. So the original rock body is usually modified. So right, right. So now, so original rock is modified. So it is, which is deformation. So the original rock body is usually undeformed and it can be modified by foldings. Remember this word, folding. Folding. Folding and jointing and faulting are under the effect of gravity. So this is called false, folds, joints, right? So let us discuss these three types of deformation that are caused mainly by the horizontal movements of the lithospheric plates. It is relative to one another. So these forces are, you see here, tensional forces and compressive forces and shearing forces, right? Tensional, compressive, and shearing forces. So what is the tensional forces? So these are stretch and pull rock masses apart. And compressive means squeeze and shorten rock masses. And shearing forces. These are push two parts of rock masses in opposite directions, right? So if a rock mass is subjected to directed force for a short period of time, it is usually undergoes through this three forces, right? Are these three stages of deformation, right? So tensional, compressive, and shearing. These three stages of deformation, right? So initially, the deformation is elastic. Remember this word elastic. E-L-A-S-T-I-C. So elastic, and on withdrawal of stress, the body returns to its original form, right? So the limiting stress is called elastic limit. Elastic limit. Okay. So now the deformation is plastic. This is elastic. This is plastic. E-L-A-S-T-A. So plastic, when the stress exceeds the elastic limit, when the stress exceeds the elastic limits, that is the body only partially returns to its original shape, even if the stress is withdrawn, right? This is the plastic limit, right? So when there is a stress continuously increases, one or more fracture develops, and the body eventually fails by rupture, right? Fails by rupture. So some examples, ductile and brittle. So the ductile, D-U-C T-I-L-E, ductile, and brittle, B-R-I-T-T-L-E, brittle. So these are two commonly used terms by the structural geologists. Those are brittle deformation. That is, brittle deformation, it relates to the fracturing of the rock. Fracturing of the rock. And ductile deformation is indicates bending or stretching and foldings, thinnings of rocks and relining of grains. That is ductile deformation. What is the brittle deformation? That is relates to the fracturing of the rock. Fractures. Remember this word. Brittle is fracturing of the rock. Ductile deformation indicates bending, stretching, folding, and thinning, right? So now, so this is the important thing in your structural geology. These two words, remember this. So, dip and strike. What is that? Dip and strike. So this is very, 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 very important words in your structural geology studies, right? So now, initially, the sedimentary rocks, those are deposited on flat, right? Flat or gently inclined surfaces. Flat or gently inclined. This is inclined, this is inclined, right? Gently inclined surfaces. So, and post-depositional deformation that is caused by the movements due to tectonic forces acting on the rock body or mass. So, which causes the tilting of the beds, right? Tilting of the beds. So, now you see here, what is the dip? Dip, it is defined as inclination of the bedding plane with respect to horizontal, right? So it is measured in vertical plane lying at right angles to the strike of the bedding. This is dip. Now it is the geographical direction of a line produced by intersection between what is that inclined layer and horizontal plane. Inclined layer in horizontal plane. So that is parallel to the surface of the earth. Right? So this is definition of dip and this is strike. Right? So dip and strike. So now the direction of dip. What is that? Direction of dip. Direction. Right? Direction of dip. D-I-P. Dip. So what is that? It is the geographical direction along which is a bed has maximum slope. Bed has maximum slope. That is called direction of dip. And amount of dip. What is the amount of dip? A-M-O-U-N-T. Amount of dip. It is the angle which is varies from 0 to 90 degrees. 0 to 90 degrees according to the inclination of the bed. According to the inclination of the bed. So now the deposition of the beds, it can be, you see here, horizontal and inclined or tilted and vertical. Right? So the deposition of the beds can be classified into horizontal, inclined or tilted and or vertical. These are the three types, right? So horizontal means, so in this angle of dip is 0 degree. It means there is no dip, right? 0 degrees. So inclined or tilted, it means angle of dip, it varying between 0 degrees to 90 degrees. So degrees, some small mistakes here. Degrees means here, right? Degrees. So typing mistake. So 0 to 19 degrees. And vertical. Vertical means, so angle of dip is only 90 degrees. So horizontal means dip is 0. It means no dip angle. Inclined or tilted means it is 0 to 90 degrees. And vertical angle means dip is 90 degrees only. Right? Remember this word. So deposition of the beds, horizontal, inclined, and vertical, right? So now, so the dip is the vector quantity as it has both direction and amount, right? Direction and amount, okay? So the amount of dip, remember this word, amount of dip denotes the angle of the bed inclination with respect to the horizontal. What is that? Horizontal. So strike is a scalar quantity because it has only direction. It has only direction and no magnitude, right? Only direction and no magnitude. And strike of the bed is independent of its amount of, what is that? Dip. Independent of its amount of dip, right? So now here, angle of dip is 0 degrees. See this picture, 0 degrees, right? And here 0 to 90 degrees. And here 90 degrees only, right? 90 degrees only. You see this horizontal angle. This is the horizontal angle, right? Horizontal angles. Horizontal angle, and this is the inclined or tilted angle or dip, angle of the dip, and this is the vertical angle of dip is here 90 degrees and 0 to 90 degrees, and here 0 degrees. It means no dip here, right? So horizontal, inclined, and vertical. So now, so true, what is the true and apparent dip? So true and apparent dip. So now see here, this is the true dip. And apparent dip. Apparent true dip, right? So dip can be two types. What is that? True dip and apparent dip. Remember this word, strike and dip is there. So dip, in the dip, true and apparent dips, these are two types in the dip. So now, what is the true dip? The maximum amount of inclination, the maximum amount of inclination or slope of bed along a line perpendicular to the strikes. Remember this word, perpendicular to the strike is the maximum slope with respect to horizon. It is called true dip, right? What is that? Perpendicular to the strike is the maximum slope, right? And apparent dip, it means the dip of bed measures in any direction other than that of true dip is called apparent dip. This the bed measured in any directions. Okay, so the amount of apparent dip is always less than, remember this, less than amount of true dip. Amount of this true dip, right? The amount of apparent dip is always less than amount of true dip. Okay? So now we're going to relationship between dip and strike. What is the relationship? So now the direction of dip and strike, right? So the direction of dip and strike of any incline or tilted bed, it must lie at right angles to each other, So thus, this true dip is in the direction perpendicular the strike. So while mentioning the attitude of any inclined bed and dip amount and dip and strike direction, it should be mentioned. So now, what is the importance of strike and dip? Anybody? Okay, now, so the importance of this strike or dip and strike in structural geology. First one is the determination of the younger bed or formation. Younger bed. First one is determination. Determination of the younger bed or formation. Right? So what is this determination of the younger bed? So in geological formations, the older rocks deposits at the base, which is superimposed by the younger rocks, right? Younger rocks. Hence, so in a tilted rock sequence, when we move in the direction of dip, then relatively bits of younger age, it will be encountered and vice versa, right? So next one is classification of geological structures. Classification of geological structures. So what does this mean? So in this, the dip and strike data, it provides useful information in the classification of rock or geological structures, right? Geological structures. So now you see here the true dip and apparent dip and relation between dip and strike directions. You see here PQRS. PQRS, right? This one. P, this one. Q, this one. R, this one S, right? So this PQRS is a horizontal plane. So beds are all dipping at 60 degrees towards east and they strike north-south. Strike north-south, right? So now, this is important thing. So now this is the clinometer compass. So this is the important thing in your structural geology. While when you are going to the field, you should take this clinometer compass, right? This must and should in the field, right? So we have already studied so many rocks, right? so many show planar structures. Planar, Planar, planar structures in the form of bedding plate or foliation. In any outcrop, I already told what is the outcrop. It means surface of the earth, right? So they are not always horizontal. It may show inclination of varying amounts, right? So we have discussed that strike and dip, right? So that describe the attitude of rock layer in an outcrop, right? So now let us recall the strike. Strike is the compass direction of a line formed by the intersection of a rock layer, rock layer. That is surface with horizontal surface, right? So now where is the dip? Dip is measured at right angles to the strike. Right angles to the strike, and it is simply the amount of tilting, right? Simply the amount of tilting, or in other words, the angle at which the rock layer is inclined from the horizontal. Inclined from the horizontal, right? So the amount of dip of a bedding plane, that is varies, right? So in order to understand the attitude and orientation of the rock structures, so you are required to measure their dip and strike on the outcrops during the field work, right? So the measurement is done with the help of this clinometer compass. You see these figures, clinometer compass, right? So the clinometer compass consists of a compass and clinometer. Compass and clinometer, right? So the compass has a circular dial, right? Circular dial, round. It means round dial, which is anti-clockwise graduated with 360. How many? 360 divisions in the outermost circle for reading the direction, right? So this circle is called, remember this word, AZI azimuthal. 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 Azimuthal circle. What is that? So 360 divisions in the outermost circle for reading the direction, that is called azimuthal circle. So where 0 or 360 degree represent for north. 0 or 360. 0 or 360, it represents the north direction. And 90 for 0 or 360. 360, it represents north, right? So, and 90 degrees for east, right? And 180 degrees for south, and 270 degrees for west. Remember this. So 0 or 360 degrees it represents for the north side, and 19 degrees for east side, and 180 degrees for south, and 270 degrees for west direction. So it has a magnetic needle which rests in north-south, right? north, south at marked end of this magnetic needle. Here, okay? This one. Okay? So one of the inner circle here, this inner circles on the dial is also marked with direction such as here east, northeast, northeast, west, etc. Right? So in supplement to the outermost circle to read the direction directly. You can read the directly these directions, right? So the inclination of a line with respect to horizontal is read with the help of clinometer fitted in compass, right? So it has a frame with open space within the clinometer frame, which allows seeing one of the inner circles in the dial marked with 0 to 90. 0 to 90 gradation, right? So the reading of inclination, which may be variable between horizontal to vertical. It means 0 to 90 degrees. 0 means horizontal and vertical is 90 degrees. Is measured with the help of a mark in the middle of the frame opening here, right? So the bridge fitted outside the dial, it helps in taking reading of the inclination of the bed, right? So the bed is movable, which can rotate up to, what is the degrees? 90 degrees. 90 degrees angles from a plane parallel to the dial up to a plane perpendicular to the dial, right? So the bridge line is always parallel to the north-south line of the dial. What is that? North-south line of the dial. So the looking device is present outside the dial ring, which on, so this pressing lock, right? Pressing locks the magnetic needle as well as clinometer so that the reading may be noted even after moving the compass from outcraft. Right? So this is the clinometer compass. So they are asking in your examination in 5 marks question, compass or clinometer compass. Right? So that is 5 marks question. So now you can draw this figure and write the briefly about this compass, right? Now, how to measuring strike and dip of an inclined bed. Right? So now we have some of the following procedures to measure the strike and dip of the bed. First one is to measure the strike direction. First one is measure the strike direction. So, to measure the strike direction, they place the compass on bedding plane in so that the bridge of the compass touches the some bedding planes completely, right? So then rotate the compass so as to ensure that the bridge becomes horizontal and one end of the bridge, it still touches the bedding plane. So now let the magnetic needle. So this one, this magnetic needle, it moves freely in the compass, right? So let the needle come to rest in, then read both ends of the azimuthal circle, which represent strike. What is azimuthal circle? So the circular dial, which is anti-clockwise graduated with 360 divisions in the outermost circle for reading the direction. That is called azimuthal circle, right? So now, in order to measure the amount of dip, second one is amount of dip. Amount of dip of the bed, draw a line on the bed perpendicular to the stripe and keep the bridge on the bedding planes along this line in such a way that the dial plane is vertical. So the reading is clinometer gives the amount of the dip amount, right? So and next one is in order to measure the direction of the dip. So first one is measure the strike direction and second one is amount of dip and third one is direction of dip. So in that, place the bridge along the line drawn the bedding plane so that the dial face the sky. It means upside. So the dial face is the sky. So the rotate the compass to horizontal so that the bridge and north-south line of the dial, it both remain parallel to the line, right? So the crown is often marked as north. Marked as north. So take the crown in the dial it towards the dip direction of the bed. Dip direction of the bed, right? So on the rotation of clinometer to the horizontal, the north marked end of the magnetic needle gives the dip direction. Now you can check your reading. Then the true dip and strike directions are always perpendicular to each other. Perpendicular to each other. Right? Now, societal benefits of the studying of this structural geology. So what are the societal benefits? SOCIETAL, societal benefits. So the structural geologist has significant role to perform for the benefit of society. So now let's discuss about this. First one is, you see here, first one is, it is important for planning mining activity. Planning for mining activity. And the second thing is, the crust of the earth is structurally very complicated. Very complicated. So it has undergone many modifications in the geological time scale. So the study of structural geology enables our understanding in unraveling, right? Understanding in unraveling the mysteries of the earth surface or earth crust, right? And third one is exploration and mapping and also exploitations. Exploration, mapping and exploitation of earth resources is depend on careful interpretations of structural geologists, right? And fourth one is artificial. So artificial groundwater recharge or artificial groundwater recharge projects. And also some of the rainwater harvesting techniques. All of you know what is the rainwater harvesting. So in your homes or in your apartments, you can see this harvesting system, right? So artificial groundwater recharge projects and also rainwater harvesting techniques that requires study of structural features of the geological terrain. And then fifth one is the selection of site engineering project. Those are depends on its structural setting. What is that? It is depending on structural settings, right? So the sites are even changed or rejected due to adverse structural setting. That is the main thing, right? So it can change or rejected due to adverse structural settings. So it is said civilization exists with geological consent, and also ancient civilizations existed along the some of the river valley projects, which usually flow along major geological features or geological structures, right? So this is the structural geology introduction. Today topic is introduction in structural geology. So now we discussed about structural introduction. In that we learn about what is structural geology and relationship between structural geology and tectonics, right? And basic concepts of structural geology, and also some of the layers and beds and bedding planes and lamination and stratifications, right? So in that we have two foliations is there, and primary and secondary foliations, right? And also intrusions and deformations. So in deformations, those are three forces are there, that is tensional forces, comprehensive and shearing forces, right? Okay. So, and also outcrops, and dip and strike. This is main important, right? So in your examination, they are asking what is the dip and strike. So you can write this thing, this one. So dip is defined as inclination of the bedding plane with respect to horizontal, and it is measured in a vertical plane. It is measured in a vertical plane. So this is horizontal plane. So vertical plane lying at right angles to the strike of the beddings, right? And strike is the geographical direction of a line produced by intersection between inclined layer, right? Inclined layer and horizontal plane. Between what is that? Inclined layer and horizontal plane. So these two things you should remember these two things. So in your examination, coming there, right? So now today class is over. Okay. We'll take the class in next Sunday. Okay. Okay. So now I want to close the this session. Okay.